you guys. I appreciate you taking the time to come out and visit with us. Obviously, this is one of those things that we love to do. What a better deal than to work all year and then get a group of interested people to come out and listen to you talk about what you did all day. That's great. But it's really nice to get to see everybody. Now, I recognize that at least half of you didn't come to see or hear me or Nicholas. You came to talk to each other. But that's cool too, right? It's been a long time since we've been able to get together outside of anybody besides friends, close friends and family. And so it's certainly great to see everyone and remake those acquaintances. So when I was talking to Joseph about what I might contribute to the program, I didn't really have any plots here, and I was trying to think on how I could contribute to the program, but really not be on the hook for anything I said. So I thought, weather that's the thing, right? Weather. So I'll tell you guys a funny story. So when I grew up in far southwest Oklahoma, and with all the tornadoes and severe weather, there's been a huge amount of money studying weather in Oklahoma. And so when you turn on the TV, in the morning, the weather, Channel 4 would say it was going to be 86 for a high today, and Channel 9 would come on and tell you it was going to be 83 and why it wasn't going to be 86. And then I moved to Virginia, especially in southwest Virginia, and you turn the TV on in the morning, and the Channel 10 guy would say, you're going to be in the high 70s, maybe low 80s, might get to the high 80s, we'll tell you tonight. I'm like, what use are you, It was just a culture shock for me to go from one to the other. But we're really not going to talk about that today. I just wanted to share some data trends and some things that I'm seeing going on with our weather in recent years, and how that would or should influence our small grain production and management sector. So before we get started, I want to ask you a question. So if you could adjust the weather, manipulate the weather at any one point in the wheat growing cycle, and it would have the greatest influence on yield, when would you do that?
May.
Right now, right? Yeah, during grain fill period. So that's the one thing that if we could lengthen that period between fertilization and that grain filling period, and when it gets too hot and shuts itself down, that's the one thing that would really reward us with high yields and good test weights. Okay? So what we want is no late spring freeze, sunny days, but mild sunny days in April, May, right? And relatively cool nights. And some rainfall, which we unfortunately have not been getting lately. But I want to talk to you about what I'm seeing with trends in temperatures. So if you look at the first figure there on the top of that sheet, this is the statewide average. So this is all the weather stations in the state averaged together. And that's the trend from 1960 to 2020 for average daily temperature. What do you see?
Getting warmer.
Getting warmer. Do we agree? Absolutely. Now the trend for May specifically isn't as dramatic, so I didn't graph it, but it's very, very much the same. It is, it's going up. Temperatures, average daily temperatures are going up in the month of May. Nighttime temperatures are up, and so that the environment in the last few years is a little bit less favorable for high wheat yields than it might have been 20, 30, 40 years ago, just based on that temperature regime. Now a lot more goes into this than just temperature, but that's a factor. Okay. Now I said May is not as dramatic, but that line's pretty dramatic, right? Okay. That's really being driven by October, November, and December, and we're going to get back to that pretty shortly. But keep that in mind. Okay, so that's temperatures. We're getting warmer, and we're staying that way. And we continue to be on that trend for the near-term future as well. So the next table there with the figures is annual rainfall here at the center. Okay, so if you look back at the decade from the 1980s, you're going to see we were about 43 inches a year, then 44, then 44. But for the last decade, ending in 2020, we're just slightly over 49 inches. So more rain than we were getting in the past. You guys also agree with that?
Mm-hmm.
What does that mean? Well, potentially that's a really good thing, especially in these sandy soils, right? I mean, having a little more moisture is always good. But there are probably times when it's bad, right? So we need to think about, managing soils for as good, infiltration to be as high as we can get it. We want soils to, as my colleagues in NRCS say, we want the soils to be a sponge, right? We want to be able to collect, infiltrate, and hold that moisture, that extra rainfall that we're getting, because we need to, right? We don't want it leaching through. We don't want it running off. We want it staying in the field so we can take advantage of it. So that's about, building soil quality, building soil organic matter, limiting tillage as much as we can to try to help increase that aggregate stability and that infiltration rate and that water holding capacity. So that's a piece of that. Now the next one, I'm going to try to explain. I'm sorry I did a poor job of labeling this graph, but the weather data also includes daily, so the highest rainfall day of every month. So it might be 0.8 of an inch, might be 1.8 inches, okay? But that's just, how the highest rainfall day of that month, by month. And I'm comparing data from the 1980s to the decade of ending in 2020, so the teens, right? And if you look, our max rainfall days were the same in January as they were in the 1980s, right? They were a little less intense in February and a lot less intense in March than they used to be. So you go back to the 1980s, we were getting a lot more individual high rainfall days in March than we did in the 2010s, right? But then the trend turns around and we see, greater intensity rainfalls in April, a lot greater in June, somewhat greater in July, and then very much so again in October, November, and December. Okay? I think most of you would recognize this, is that you're seeing, when it rains, last year it didn't rain tenths, it rained inches every time it rained. Now that has impact on us in a couple of ways, and small grains somewhat indirectly, especially in those wintertime rains. A few years ago, I spent a lot of time working with the Russell II soil erosion prediction equations. And what we were actually working on behalf of the Chesapeake Bay Program Partnership, put some numbers in the Chesapeake Bay model about how much soil residue cover we needed to get what level of protection we got with different levels of soil residue cover. So we were trying to we modeled it, then we did some validation on that. The point is that with this high intensity rainfall, anybody seeing more erosion, more gullies, even in fields that have been in long-term no-till than you had in the past, right? Mm-hmm. Right, we're getting that more intense rainfall, and it's causing us more erosion problems, especially in that gully type stuff. Okay. Based on this residue work, we want to keep at least 60% residue cover on the surface of the soil the entire year, and that's about as protective as we can be. More is slightly better, but you really need to get to that 60% to really help yourself and limit surface erosion. Okay. And all those models we ran in Central Virginia, if you just have a corn and soybean rotation, it's very, very difficult to keep that 60% residue cover on that ground all year round. At the end of that bean cycle, right before you plant corn, it's oftentimes 50% residue cover or less with just corn and beans, right? Even in a long-term continuous no-till system. But you add wheat into that rotation, and it's almost every time you had residue cover more than 85% of that field year-round. Okay, so having small grain in the rotation is going to be extremely beneficial to helping us prevent and fight erosion because of that additional ground cover. I just have more stuff out there to intercept those raindrops and to stop that flow down slope. Okay, so and I'll say this too. Cash wheat, cash barley would certainly be my preference, but if we're not doing that, we need a cover crop in those systems. We're going to need to protect that soil, and it's going to be more important for us to do that now than it might have been 20 or 30 years ago because of the intensity of that rainfall. So we've got to think about making sure to tweak those cropping systems so that we maintain that residue coverage in those fields. Okay, questions or comments about that?
Small grains, good for the rotation, I agree, but ours would be the ones you really want to plant, right?
Yeah, absolutely. Nicholas will guarantee that the erosion control benefits of Virginia Tech release varieties are better than all others.
Oh, far outweigh.
On the record. We're on the record.
So Wade, this information, how does this change, or with this knowledge, how should we adapt our planting dates? Or is that, have you gotten that far yet?
That's where we're going next.
All right, I have a question.
No, it's actually the perfect segue for me, because the backside is a couple of maps of the state of Virginia. And let me try to set the scene here. So what this is showing you in that, say that top figure, is if you started on December 31st and went backwards into the fall, this was the date you would have had to start counting to accumulate 700 growing degree days per week. Okay? And 700 growing degree days is roughly about 3 tillers development annually. So growth stage 23 at the end of the year, which is, probably about where we want to be as far as a crop that's fairly well developed but not too far along. Okay? So that's that 700 growing degree day line. So let's focus now for this discussion just here on Eastern Virginia. And let's look at the sites where we have data from the northern neck. If you looked at that period, the top figure is 1981 to 2010, this historic period. What would have been the optimum week to plant wheat right here? October 15th to 20th, right? Agreed? Mm-hmm. Yeah, absolutely. Okay. And that's been the recommendation for quite some time. But I want you guys to look at what's changed in Eastern Virginia in that period from 2007 to 2017. And I have to admit, I need to update this, but the postdoc that I had doing this work for me left, so I hadn't gotten back into the database and the GIS. But that 7-year period, look what happened to the northern coastal plain and the northern neck. That 700 growing degree day accumulation is, you can get that a week later, right? So what that probably means for us is that our planting dates potentially need to be a little bit later than they might be if you haven't shifted in 25 years, right? Because we're seeing changes in temperature. We're seeing more heat accumulation in October, November, December than we used to. And so, those plants, if planted on the same date, they're experiencing more heat, so they're further advanced. They're farther along now than they would have been planted on the same date 30 years ago. And if you look at Virginia Beach, Suffolk, down at Tier counties in far southeast Virginia, you see we added a whole new week that we didn't have in that period from 1980 to 2010. Okay, so that's where we're progressing. Is these temperatures are we're staying warmer later in the fall, and so we're getting more growth. Now you combine that with the fact that our winter is being somewhat compressed, but our spring freeze date, our last spring freeze date, is really not different than it was in that 30-year period ending in 2010. Right? I mean, you guys all remember what happened to us last year, and we had some cold injury just a few weeks ago. So we're in a catch-22 because if we're planting at the same time we were, our crop is further along, it's further developed, but we're still facing that same freeze date. So that's my hypothesis on why we're continuing to see more and more freeze injury. Our wheat and small grain crops are further advanced, they're further developed than they would have been a number of years ago based on this greater accumulation of heat. And so, they're being hit harder by those cold temperatures than they might have otherwise. So that's, I think, in a nutshell, what we're looking at in terms of the changes in rainfall and temperature, and what I'm thinking that we need to plan on in terms of management to try to help deal with that.
Do you have average harvest dates over those same years?
I haven't looked at it. I can tell you that last year was the first time in the 17 years I've been in the state that we harvested barley in May. But I can look at it. I can check that. I've had about 4 interesting questions on the influence of that, and that's another good one. I'll look into that. Thoughts, comments?
It was a long harvest year last year. We were still harvesting wheat in Blacksburg after July 4th, which is really unusual for us. Yeah. I don't know if it stretched out. I wasn't here for it.
Yeah, it kind of got stretched out, so because of rain.
Rainfall.
Yeah, rainfall in June increases.
Yeah.
Yeah, I think we all sat and watched it rain for a week last June. Before I let you guys go, I just wanted to hit one thing. I'm also the corn extension specialist, and I know that all you farmers in the group have noticed that it hasn't rained in a while, and there's not much chance for rain in the 10-day forecast, right? It's also, we were on the Middle Peninsula and Northern Neck yesterday, and the corn's V5, V6 in a lot of those fields, V4, 12, 15 inches tall. It's time to side dress if you haven't, and yet we're facing a scenario where it doesn't look like there's any rainfall in the near future. I'm concerned that if we're putting side dress out now with no rainfall in sight, we have you know, a strong potential for significant volatilization losses of ammonia. And so I'm just going to say be cautious about that. If you're going to do it, make sure to try to use an inhibitor and hold that together. But my experience with that is you're buying yourself 5 to 7 days. It's not 10 to 14. Losses, I've seen losses upwards of 15 to 18% of the total N applied through volatilization. So in the coming weeks, just be cautious about those potential losses. And if you have any further questions, Dr. Alley's here. He's actually an expert in this area, and you should see him if you actually want to know any of the details. My comment there is just be cautious about putting nitrogen fertilizer out on the ground right now and ended up with greater losses. And with what we're paying this year, you certainly don't want to lose it. Questions, thoughts?